When the pH is 7, then it's a case where the sample is neither acid nor base. But less than 7, it's an acid, we say. More than 7, it's a base all the way.
Welcome to one of the past HSC exam question videos. In this video we'll cover this exam question, which comes from the Theory of Acids and Bases chapter. While I'll do in a second, I'll read the actual question. Once I've read the question, give about 5 seconds to pause the video. Once you pause the video, attempt the question, and then press play when you're ready. So the question itself is: explain how a buffer works with reference to a specific example in a natural system. And that's worth 4 marks. So when you're ready, pause the video and attempt the question. Welcome back. Alright, so the question itself says explain how a buffer system works. So we have to go through the general idea of buffer systems, but it also says with reference to a specific example in a natural system. So in this case, I'm going to talk about the blood and carbonic acid and hydrogen carbonate and how they work together to maintain our pH in our blood. So what you should do first is you should have just a general definition of a buffer system, what that is. That you have a weak acid and its conjugate base in equal proportions, and how that helps us to make sure that if we have too many hydrogen ions in our solution, that the pH doesn't change, and if we have too much hydroxide solution in our system, how the pH also doesn't change. So if the solution is either becoming too basic or too acidic, that there will be a counteract in effect, and overall the pH will stay the same. So that is our general statement, and then we go into a specific example. And then you should maybe even have an equation. That'd be useful, having an equation of that specific example, and just going for the same idea of how that system works to make sure our pH is maintained. And what you could also do is you could maybe even go through why that's important, so why the natural system has to maintain the pH. So what I wrote first is a buffer system consists of a weak acid in equilibrium with similar concentrations of its conjugate base. So we have a weak acid and its conjugate base, and the concentrations for them are both quite similar. Then what I wrote next is when excess hydrogen ions are added to a system, so when we have too many hydrogen ions which are added to a system, which would usually lower the pH, the conjugate base will accept the ion in an effort to minimize pH change. So in this case, our conjugate base will become active to make sure that there's no change in our pH. On the flip side, when we have excess hydroxide ions, which will usually make the pH go too high, so when excess hydroxide ions are added to the system, the weak acid will donate a hydrogen ion to the hydroxide ion to form water. This is also done to minimize a change in pH. So here we've just quickly described the general nature of our buffer systems and how they help us to minimize any change in pH by either the conjugate base accepting a proton or the weak acid donating a proton, depending on what happens to solution. As this was our general statement, and then we're going to go cover the actual specific example. So the carbonic acid hydrogen carbonate buffer system is a natural system that occurs in our blood and helps maintain a stable pH. So here we've mentioned where it occurs naturally in our blood. Obviously it does the same thing, it helps us to stabilize our pH. Again, I mentioned it would be good to have an equation. This is the equation. Carbonic acid plus water goes into hydrogen carbonate plus hydronium ions. This is the equation. And then I quickly wrote, this part here is just writing about why we need to have a narrow range for our pH in our blood and in our body. The pH needs to be maintained within a narrow limit as the body's enzymes only function within that narrow limit. So that's why we need to keep a narrow limit, because our body's enzymes will stop functioning otherwise. So a change in pH will result in less enzyme activity and subsequent damage to the body. So obviously that's why we want to maintain that pH. And then what I go for next is just generally how that system works. Going through both what happens when we have too much hydroxide and too much hydronium ions in solution. So what I wrote first is when hydroxide ions are added to the blood, and that usually would mean our pH would increase. So when that happens, the carbonic acid donates a hydrogen ion to form water. So in this case, this here will donate a hydrogen to a hydroxide ion, and that means the hydroxide ion will become H2O. So the carbonic acid donates a hydrogen ion to form water, and thereby minimizing an increase in pH. So the hydroxide ion is no longer there, it's now turned into a water molecule. On the flip side, when hydronium ions are added to the blood, so now we have hydronium ions, which are the H3O ones. Now we have more of these being added. So when that happens, hydrogen carbonate ions accept an hydrogen. So now this one of the hydrogens will be put onto the conjugate base, the hydrogen carbonate ion. So the hydrogen carbonate ion accepts an hydrogen ion from the hydronium ion, and as a result produces carbonic acid and water, thereby avoiding a decrease in pH. So again, we have avoided that decrease in pH, which means it's not acidic, it stays at our neutral pH, and overall everything is good. So that's the example. And now I'll just also quickly mention what happens if we have way too much acid or base in our body. The system will stop working if too many hydroxide or hydronium ions flood the system. So this only works if there's an okay amount of acid or base being added. If it's way too much, then the system will overload and also fail as well. Which is one of the reasons why we have to get rid of carbon dioxide, because carbon dioxide causes our blood to become acidic, which is okay if there's small amounts, but if there's too much, we have problems. As in this case, it's worth 4 marks. You will get quite a few marks for just quickly mentioning what a buffer system is, that quick definition up here. And also what the general definition or general way a buffer system works. And then for linking that to a natural system, so our natural system, you'll get a point for the way what happens when our hydroxide levels have increased or when hydronium levels increased, and linking that to the carbonic acid and hydrogen carbonate ion buffer system. That's worth your 4 marks out of 4. And where that question came from, it came from this dot point. Qualitatively describe the effect of buffer systems with reference to a specific example in a natural system. Right, so more or less exactly that question is our syllabus dot point. I hope that was useful.
Thank you for watching.